I'm very grateful to be invited to give a talk to you all. I personally do not know you, the people on the table, so that will be on another occasion that we can have more personal contact, and probably in the next Trustworthy AI Summit that will be organized next year in the Netherlands.
Yes, with pleasure.
Yeah, yeah. Well, I can give a brief introduction to my background. I work in machine learning for a long time, since after graduating from the university. Did my PhD in computer vision mainly, and then at various institutions, and always also, as we say in Dutch, one leg in the university. So always doing also research at universities, supervising master students, PhD students, etc. And since I work at TNO, that's now almost 8 years, yeah. I focus more and more on trustworthy aspects of machine learning, of artificial intelligence. And then within the trustworthiness, mostly on bias fairness, and also somewhat on transparency and explainability. Within TNO, I am lead scientist of the TNO-wide AI program, which is called Apply. You might have heard about it because I think Freek already explained that program. There we do research in topics that I will discuss later, and we do it mostly domain agnostic. So we work on more generic tooling that can be applied further to all the TNO domains that TNO is working on. Very briefly, TNO works in safety, security, the health domain, energy transition, logistics, mobility, well, the AI technology itself, the core technology that's in the department or in the units that I'm working myself, but also policy research related to AI, of course, also. So many different sectors and domains that are covered in TNO. And in this Apply program, we work mostly on generic tooling for the other units. What will be the topic of today? Yeah, it works. The topic of today is centered indeed around this Apply program, this generic TNO-wide AI program, which was founded on a research strategy that we made first. And I will explain a bit about this research strategy and then how we implemented this strategy into, say, something actionable. And then I will give some examples of research results, and you can imagine after, what is it now, 7 years of running this program with quite some investments, that it's only a very little bit of what we have achieved through the years. I also kept the results a bit closer to my own topics and also to the things that I believe fit your interests. Yeah, so this research strategy, we developed that in 2021. So that was just a bit after the start of the program, to have some more guidance in our research. So we had some generic guidance for the research program, like Trustworthy AI was already upcoming in this time, and but we were developing tools and research, which was a bit more for autonomous systems, and some was a bit more for decision support systems. But in total, we wanted to develop a bit more looking ahead and a bit more over the horizon of those days, because I think we had 3 years for the program to go. By the way, I show here the link, but the link doesn't work. Maybe if I would share the PDF, I'm not sure, but this document is available on the website of TNO. What we used for the research entity is that we foresaw, I have to say, because it's a few years ago, but I still think it's still applicable, that the AI systems would and will develop in 4 dimensions. And one of these dimensions is that, say, early on, systems would be made for one specific purpose. And we see that the purpose will be multi-purpose and gradually more towards autonomy. And that besides that the purpose can change, also the environment can be less controlled. So you could have like an assembly robot, which is very controlled in fixed position, and there is a band going under the robot that is fully controlled, all the objects. But it could be that the same robot is used for cars and for other things that or small parts that can be on the band that it picks and assembles. But still the environment is quite controlled. And if we look at the autonomous car, for instance, then it's completely different. There's many other traffic vehicles that are on the road, and pedestrians and bicycles, and the roads differ and the weather changes, and so that's completely different. Especially for decision support systems, we looked at aspects as working standalone. So the traditional person working with one PC and having some user interface and some indication, some information sharing, towards multiple people with multiple systems sharing information at different levels of complexity, conceptuality, more like a heterogeneous teams. And the last one that is maybe the most related to the trustworthiness in the legal aspects that we're nowadays involved with, the governance of AI systems. You can think of a game, the chess playing machine versus autonomous cars, by the way, also, but think of the military domain where drones and things like that go on a mission with high-level goals, but also decision-making systems for, say, fraud detection. Then also the governance is very critical, because it's about people, fundamental rights, things like discrimination that is potentially happening. Well, I think in all our countries, at least in our country, we have had few examples, but still too many examples of that. It makes us fully aware of the risks that we can have. So we decided to approach this world of AI systems in 2 separate ways. And we also decided to make separate roadmaps, a roadmap for autonomous systems and a roadmap for decision support systems. And these aspects, these trends that I showed on the previous slide, they have all impact for both system classes, but in a different way, and also sometimes more impactful than in other cases. We had a third roadmap that you can find if you download the document, which is about system engineering and lifecycle management. So that's more about how to build systems like these types of systems for lifetime, so to say, that you don't have to break them down after a few years because they don't work anymore or not good enough anymore, and so that there is a continuous monitoring system validation, verification kind of cycle, and that the system works also if the world changes, if you have to reinstall maybe new software versions, and all that. But that's not the topic of today. So I will mostly focus on the roadmap for decision support system. So that's the right part of the previous slide. And there we have defined 4 milestones in the roadmap. And the roadmap had a window of approximately, we defined it to be 10 years, with the intention of adapting it through the years, so that it's not like we can foresee in 10 years what is going to happen. Remember that I think it was after when we did ChatGPT arise. Was it 2 years ago or 3? I'm not sure, but this was before ChatGPT. So indeed, there was enough reason to reconsider the roadmap, which we did not do for other reasons. But yeah, the world has indeed changed. So looking ahead 10 years is indeed a lot. But that was, say, the intention to have at least a focus point. Like we try to do with the best of our knowledge, look ahead what could happen. And these milestones that we defined is not like that we consider it really like endpoints. And so that after a certain point, we stop with research because it's done and then we go to the next point. It's more like some identifiable points for our own investments. So that we first have focus on the first milestone, and then at some point we consider that we have the capabilities to build systems with such functionality, and then we continue. And it's not done because, as we all know, that systems have all kind of properties and functionalities required for certain domains and for certain data types and for certain knowledge levels of the users. And so there's a lot involved that you cannot consider done at some point. So the first was just, you could say, reliable decision support, so a system that has a certain level of performance that you can use, a certain stability. Then we went on to role-based decision support, where we defined 3 types of users of the system, being a researcher. And researcher is, say, domain researcher. So the medical domain usually talks easily. Then the domain researcher would be somebody, for instance, interested in diabetes, the disease diabetes type 2. And that person is interested in information on the population level. So not like individuals and predictions for individuals, but how does diabetes type 2 really be different between certain populations, between the countryside and the city, or age, what is the role of age, and so really at population level. At the other end, we have the subject, and that is for diabetes prediction would be really a person about whom the prediction is being made. And you can imagine that, for instance, information about how the decision was made by the system, or the advice, you should actually say. So the type of explanation, but still then you can differentiate between the type of the subjects, the patients. And in between we have the consultant, and the consultant is a person who sees many more subjects and is able to comprehend the information from the system at a more specialistic level. It's more like it's an expert and is able to translate technical information from the domain into language that is suitable for the subject, the patient, for instance. The third milestones that we defined, we called trustworthy decision support. So that is aiming at having all the capabilities and functionalities to be compliant to the, at that time, still in development being AI Act, inspired, of course, by what you all know, the Trustworthy AI requirements from the high-level expert group. And that was including the tensions that we see that can be in place between, for instance, privacy and transparency, or bias and explainability. And these topics came more and more into focus in this third stage. And actually, that's where we more or less are at the moment. And the last stage is federated decision support, so that's more focusing on having multiple systems with multiple users. And that's where we not yet are, although we have been and are developing tooling for instance, having multiple databases and being privacy aware for sharing some information between the different databases or different parties and other nodes, things like that. Yeah, and for these different milestone systems, we defined 4 what we called capability clusters. And here you recognize the trustworthy requirements, I expect. The top 3 rows being fairness, interaction, and confidentiality. And the last one is adaptivity, and that's one we added for 2 reasons. One, because we want to develop systems for longer lifetime. We want to be adaptive to changing environments, and so also this open world for autonomous systems. But we also want to be adaptive to the user needs, and that is more a local adaptation and also more temporal. That's not distributed to if somebody else is using the same system, for instance. And then the trustworthy requirements, fairness. So it's about debiasing data models, measuring biases. For this later stages where we think about and work on integrating fairness, interaction measures, confidentiality, etc. The last stage, also working on adversarial use. Interaction is about really interacting with the system, both in output of the system, so that's the explaining part, and also the input of the user towards the system, individualizing interaction and so on. It's not that all these things that are here that we have all studied all these topics. This is what we at that time foresaw as relevant and also fitting with say the type of technology development that fit with TNO as an organization. So TNO is an applied research institute, so we're not focusing on really the most fundamental research in proving theorems or things like that. With respect to the confidentiality dimension requirement, we worked mostly on techniques for sharing data between parties. So that's that federated part, where the sharing can be in a what is called vertical way, where one party has, for instance, say personal data about someone with respect to work, and in another database there is information about the same person about maybe medical background. And if you would bring these together, that's what's called vertical separated data. And horizontally would be if you would have in one database persons with all these kinds of information, and you add from another database other persons with similar information. We work mostly on vertically separated data for bringing data, say, virtually together without really bringing the data together in one central database. We mostly use their multi-party computation technology. I think this is enough for now. Yeah, so having such a roadmap for autonomous systems and for decision support systems and also for lifecycle management. But here we show the autonomous systems and the decision support systems. We had the program, the apply program, to implement and to make all these ideas, make that actionable. And we did that at several levels. The lowest level, if you like, we call scientific exploration, and that's where we have funding for collaboration with universities. We do some collaboration in co-supervision of PhD students at the university, and in some cases we pay PhD students, usually also working at universities, but sometimes also working at TNO itself. And then we try also to do the supervision, because that makes the control of the research directions towards our own ideas and our own roadmap was easier. The middle level that you see is where we have what we call the Flagship project. The so-called SNOW project is for safe autonomous systems in an open world. That Flagship is, of course, about autonomous systems, and the FATE Flagship is about fair. Yeah, I forgot the abbreviation. We always used the name FATE as such, but that's about the trustworthy decision making in teams of humans and machines. And the top layer, there you see use case projects, and the use case projects are always co-funded by partners that are interested in the research itself, and they know that they don't get final products that they can implement right away. It's always co-creation, and so we work usually then maybe not even with one party together, so a few stakeholders, and then we invest with these stakeholders to do a project on say energy use and then prediction of energy use, and to adopt towards the producer of the energy, and how to do that using privacy friendly and other techniques. Indeed, about medical domain, diabetes, type 2 prediction, skills matching we worked on. I give you some examples of these use cases also in the research results that I will show in a minute. Because although these use cases might suggest that it is purely testing results in practice and making the partners happy, because we co-fund these projects, the partners also know that it is still applied research that we're doing. So in many of these use cases, it also resulted in publications. And one of the initiatives that we took for the scientific exploration is so-called ICAI lab, called AI for Oversight. That's a collaboration between TNO and 4 inspectorates and 2 universities. One of the universities is Leiden University. I work there also part-time, so that's convenient in that sense. And these ICAI labs, these ICAI collaborations are focused towards collaboration between applied research labs, for instance, where the bridge from fundamental research to applied and really application is really shortened to improve innovation in well, in this case in our country. And it's a very interesting concept. I don't know if something exists in your own environment, in your own country, but it's really interesting to consider. It's very successful. I think at the moment there are, I think, like 60 or so of these labs where per lab there is at least 6 PhD students, and sometimes there is only one stakeholder, sometimes two. In this case, it's 5 stakeholders, and then oftentimes also two universities or more. So in this case, we have indeed governmental organizations together with the as stakeholders for say trustworthy oversight for these governmental organizations and working on technology, so to improve their way of working in a trustworthy way, so that it is human-centered, that the inspectors that are going to use these tools are really not only part of a system and downgraded to push buttons, but really supported in their work. We have indeed six PhD students in this ICAI lab, AI for Oversight. One working on what we call trustworthy AI, and that's mostly on fairness kind of aspects, mitigating bias in models and bringing that mitigation process as close as possible to the decision maker. And that is maybe not per se a user, that can be the stakeholder at large, including ethicists, legal people, but how to choose the operation point of a decision support system, taking into account the accuracy of the system as well as various dimensions of the norms and values that are involved in the specific use case. Continuous learning is about starting maybe with no label data, involving trends in the data, how to obtain data that is valuable, high quality for building decision support systems. Aspects as active learning, probably known to you, are an important part of that research line. The hybrid AI is about technology very close to the inspector, to help the inspector in the tasks, in the daily tasks, really interactively, so that the inspector can go to an object for inspection, and while doing that gets advices what about the next step to do. Social simulations is about doing predictions about how policies might work out while using, for instance, decision support systems, because the decision support systems impact on the inspectees. They know at some point maybe what will be inspected and what are important points, and they might adapt their behavior, how to deal with people who make errors in their operations, are non-compliant, but some are just not knowledgeable, and other are just malicious, how to deal with it. Handling ambiguity is about all the documents that inspectors have to analyze and how to find where in the document is the information about how to comply to a certain norm. And finally, leveraging dependencies is about modeling dependencies between inspection items, and how to find out how these inspection items, which can be compliant or non-compliant, how these relate to each other, and how these may help in being more efficient in doing the inspection work. Well, that's a lot about the background of how we organize all these things. Now some examples of what we achieved in our researches. This is an example about a model for mitigating bias in a classification in the decision support system. There we usually want to optimize the accuracy of a model. Here is, in this case, it's expressed as the area under the ROC curve. The example here is some open source examples that are used often for fairness research, for measuring bias, etc. And you see different methods in the different colors in the graphs. And these are all methods that have been described in the literature for similar objectives. The difference is that the method that we described has the ability to really trade off the accuracy versus bias fairness, but really with a parameter that you can adjust, so that you really can choose an operating point that suits your own needs best. And again, as I said earlier, taking considerations from the ethicists and the legal people and policy people maybe into account what is a good point. To give an indication, like the example left top, where we have, I think the task was to predict whether somebody was going to have a high or low income based on all kind of personal attributes. And the sensitive attribute was age in this case. And there you see that you can reduce the influence of age in the model quite a bit without losing so much of accuracy in the area under the curve. I don't know if you can see my pointer, by the way, but if you look here, and so here we go down from being unfair, and we see a value of over 0.8, and we can go down to, say, 0.62, and then the accuracy is still AUC 85. And so that this, here you can see that you can trade off fairness and accuracy quite well. While in the bottom case, I still don't know if you can see my pointer, but for a recidivism race, and I think this is the COMPASS data set.
Yes, we can see that if you want to, we can see your pointer from time to time.
Okay, thank you. Here you can see that if you want to trade off the unfairness with accuracy, you see that it straight away costs you the accuracy. So here probably there's really a strong correlation between the race in this case and recidivism, and well, there's probably all kinds of sociological explanations to be given. A follow-up research that we did was, how can we help the decision maker and the team that has to decide on the operating point on what is a good model. In this case, we have 100 models, with all these points on the graph are all different models with different trade-offs between performance. In this case, it's also AUC versus fairness. In this case, it's again, I didn't mention, but it was a strong demographic parity. And we see that that there are some clusters, but the question is, what do these clusters mean, and are these clusters really different? And we, what we did here, we learned in the feature important space. Yeah, I assume that you know things like this, but otherwise, please ask me questions. These are random forests, and these random forests you can determine feature importance with Shep values. And we transformed these feature values into a metric space that takes into account the nearness in this space. Well, for next time to go in more details, but in this transform space we found clusters which learned us that, for instance, this orange cluster, which is quite extended, is probably standing out still, and it should not be cut in two. And so, but this can help you in deciding, like, because these models are very similar. And so they are similar in terms of feature importance. So that's helping the decision maker. But it is still a topic that we are exploring. This is quite recent work. Other work that on bias and fairness is about representation of the data, where we all know that in medical work, the background of people can be on influence of the way a phenomenon or a disease develops. For males and females can be different. For younger people, older people, different ethnic backgrounds. All these aspects are to a certain extent known for the medical domain. And what we did here is using some population data. This was from the north of the Netherlands. And we explored whether age, gender would influence the quality of the predictions of the model. And in a very specific way, we did that. You can see on the graph, if you go from left to right, there on the left side, we have 0 older people in the data set. On the right side, we have only older people in the data set. And the size of the data set remains the same, so that the size of the data set is not impacting the performance of the model. On the vertical axis, we see the AUC performance for younger people, older people, or a mix. Green is the mix. So what do you see? If we have only older people in the database, then the performance is the red line for older people. And with more older people in the 0% older people, I should say, then the performance is low. And if you increase the number of old people in the database, then you see that also the performance increases. And for younger people, the other way around, of course. And so you see that indeed there is information in samples from older and younger people for this case. And by the way, this was using gradient boosting for cardiovascular disease. I think I said diabetes, but this is cardiovascular disease. And if you look at gender, we don't see that same behavior. What we see there is that if we go from only females to only males, we see hardly any trend. But we do see that the model works better for males than for females. So this is food for thought for say researchers in that specific domain to find out what can be the explanation for this. There was a similar effect visible, for instance, for age. There was also a performance gap between age groups, and that can also reflect that some and that was for diabetes, and that can be an indication that, for instance, diabetes develops in a different way for younger people and for older people, so that is the reason for seeing different performance levels. And something similar could be here, that indeed for females and males the cardiovascular disease develops differently, but it's not so dependent on the amount of samples for a certain group. But that's to be investigated for people in that domain. What we did further was, like, suppose that we would be given a certain situation that we say we have only, here we start with no data at all in the corners. And then we can go that way. Then we add older people, or that way we add younger people. Well, obviously then the performance increases because then we get data at all. But here we have all older people that were available in the database. And then we have a certain performance on younger people. And here we have no young people at all, and we increase to have all the younger people, and then the performance for all young people. What you can learn here, for instance, is that say if you would have only, what is it, like 30% of the data of the young people, and that's all you have, that you can increase your performance on younger people by adding older people. And so you can learn what in your given situation with your limited data, that it can still be useful to add data of other individuals with other properties and still improve your model. This is completely different work. This is about a specific case for the labor inspectorate. The labor inspectorate has to oversee, to supervise on vacancies by companies that they are not using terms and directing vacancies only to men or only to women or only to certain age groups. That is not allowed by law, at least not in the Netherlands, but I think in general in Europe. And what the method to use is by the inspectorate, the labor inspectorate, is to do keyword search on typical words that expectedly relate to gender or to age. And so at the left side, you see the English terms, but of course the Dutch terms have been used in our case, like boy, male, female, etc., etc. And we prepared together with the people from the inspectorate a data set in which the vacancies were labeled like, okay, indeed, we see the term boy, but this is not a case of really discrimination or really bias, because it could be that it is about the vacancy that you have to work in a school where there's only boys, or with men that you are working, going to work in a prison where there's only men, or it's a hospital department only for women, or all these things can happen. And we prepared a data set in which the vacancies were flagged, were labeled by inspectors saying, okay, indeed, we see such a term, but this is, and then HSD is short for highly suspected discrimination or highly suspicious. And so from all the boys vacancies, we had almost 1,000 vacancies with the term boys, and 10% of them were indeed discrimination, and the others were just references to boys without discrimination. Well, that's the background. And then the question was from them, can you make a system to do this automatically? So indeed, we give you, because that's easy, they can do a scan and give all the vacancies with, for instance, the term boys. And then the tool would say, okay, this case, the term boy is not discrimination, or it is discrimination. So very practical. And we made a tool, and we also learned the tool for different sizes of the data set. And we let the data set run from all data to only 1% of the data. And interestingly, what you can see in the figure is that, for instance, the backup word with logistic regression, it's here, that is in the beginning performing quite well, and also the purple one, the backup words with the random forest model. And so these are the best if you have only 1% of the data, substantially better than bird, which you probably know. And but if the data that you have increases, then bird becomes clearly the best performer. And so that's interesting to see that the bird model that incorporates really contextual information can do better, but needs more information and more data to be able to do that. And the word fact models are consistently increasing with increasing data, but they're the worst performers here. What we did on top of that to get some further insight, but I think given the time, maybe I should not take too much time for it, but we did also leave one out in the, not in the number of samples, but also in terms. So can we predict whether or not a vacancy is biased, is discriminatory, in case we haven't even seen the term male, for instance, in the samples before, or other terms. And what we also did, it's also an interesting exploration. We looked at terms that we didn't know, so that's even a step further, terms that we didn't know, but the model found as potential discriminating. Now, and if you see the terms, then you see indeed, like, yeah, these terms are not on the blacklist of the inspectorate, but they could as well add them to the list. The last example that I have is about an example of the tensions that we are exploring, and we are currently also working on another one that's about bias and explainability. This is about the tension between privacy and explainability. You might be aware of counterfactual explanations. Counterfactual explanations are, well, the easiest is to work with an example. Suppose you would be predicted to get a cardiovascular disease by the system, and then you would say, oh, how come? And then a counterfactual explanation would then be, and then going to the example on the screen, there would be 3 examples of counterfactuals. These are on the other side of the decision boundary. So these are cases where there would not be cardiovascular disease predicted, and they're very similar to yourself. Yeah, so they are near to the decision boundary and the nearest to yourself. And the decision boundary can also have different shapes. So in this case, it's also not linear. And then you can compare to these cases as an explanation. In this CF1, counterfactual 1, for instance, in this plot, in this 2-dimensional plot, is only different in 1 dimension, which can be advantageous because then you have little information to compare with yourself, because then it's only 1 feature that you can compare. But to compute these counterfactual examples, you may need, for instance, with vertically distributed data, vertically shared data, which I explained some time ago, there you don't have access to all the features to compute the counterfactual examples. You don't know how to compute the distance to other samples, of which you have some features, but not all features. And you have to look up these other features in other database, which you're not always allowed to for privacy reasons. So here we work on, this is also with multi-party computational encryption technology, to get access to features that are not in your own database, but still able to compute distances to samples to find the nearest counterfactual examples. And then we have 10 minutes left for questions, Bertrand. And
yes, very good. Thank you.
I was not stopped meanwhile. So.
No. There was no hand raise or no. I just wrote a question that I'm going to ask now. So I'm opening for questions for everyone. Since while I'm waiting for others to ask questions. Okay, you have shown us you started with a big picture with a roadmap for AI, let's say in general, and then you also showed us.
Shall I close the? Oh, sorry. Shall I close the presentation, or maybe I have to browse through it? Yeah.
Oh,
yeah, okay.
As you like. So I appreciate the fact that you started from the big picture, but also show that you made a number of small steps in the direction of the big picture. Huh? So I think it's really a complete approach. But I would like to go back to the very beginning and ask you about this roadmap in 4 steps. Does it come from some existing theory, or what is it? Has it just been developed by TNO? I'm talking about the four boxes. The next slide, not this slide one. No, another one. No, yeah, this one. Because it seems very interesting to have these 4 stages. So did you get that from from some existing book or material, or did you develop that by yourself?
Yeah, I think although I have to say that, for instance, this role-based milestone development point in time, that we have seen similar things, although what we've seen in other cases was that the researcher was a data science researcher, and we believe that you can add this type of researcher also, but we believe as a user of the system, it would be the domain researcher, right? Somebody in the social domain to learn about. And I think with the data scientist as researcher, we have seen something similar at IBM. But I think it was afterwards we had made it ourselves. So yeah, maybe it's not so unique an idea. I'm not sure. Yeah, and the trustworthy point that that is at that point, of course, something that we were aiming at, and we do have a lot of experience in saying multiple systems collaborating and privacy aspects of that. And yeah, it is indeed to be expected that you get at some point multiple systems collaborating. So it is for our organization also a quite logical next step to have multiple systems working with multiple persons. So yeah, but there is no, we didn't take it from some other domain.
Okay.
Indeed.
No, it's developed by TNO. That's what I understand.
Yeah.
So Surya, please.
Hello, my name is Shreya. I'm professor of applied mathematics. Sorry for the noise. I'm in the bus now. I have to listen your webinar on the way. It's almost 6 p.m. here in Istanbul. I'm from Turkey.
No.
Also, I've been working in machine learning field since 2005 during my PhD, and then I continued. I'm the former student of Joshua Taylor. Maybe you know the old machine learning, the former pioneer.
Yeah.
I use mostly optimization in machine learning as a mathematician, and now recently I've been working in Trustworthy AI. So it was really inspiring your talk. Thanks, first of all. I'm here with my students. They are also listening together with my research. Listen to your talk. We are working also in counterfactual explanations.
Okay.
And in finding these counterfactual explanations, we add one term more, robustness term, to find the robust counterfactuals together with diversity. But as a preliminary work, we solve unconstrained optimization framework. So as a feature framework, we want to solve it as a constraint programming, moving these robustness and diversity maybe to the constraint and solve this. Maybe I would be very grateful if we can later on keep in touch and exchange with my group. I recently also funded my new startup. It's called trustai.com.tr. It's website. So it's 4 months ago. It's very new, and we are developing automated documentation for fintech companies, mostly for banks, for the credit decisions, credit scores, predictions, and evaluating their AI models, whether it is trustworthy under the compliance of this EU AI Act regulations. I'm working on this, so would be very grateful if I can email you later on and exchange with the students. And you mentioned about such research exploration in
Certainly.
your group. So maybe we don't have time. So just wanted to introduce myself, and it's not a question, but introducing and telling. Yeah.
Okay, thank you, yeah,
Put your contact in the chat so that you can do that together.
Yes, yes. Okay, I will. I actually send you a LinkedIn connection today, and I will email you about. I can send you our paper. It's published about this robustness term, published in a book chapter. We are preparing the journal article of this. So I will be very happy.
okay. Thank you,
Yeah.
thank you.
Thank you very much.
Okay, good luck. So I don't see any other hand raised, but I have another question for you. We still have 1 or 2 minutes. Yeah, I know that we always have to find some kind of compromise between the different trustworthiness attributes.
Yeah, this a world.
But the AI Act for us European citizens doesn't like this kind of compromises. I think the European regulators, they say we want unbiased, we want explainability, we want performance, we want they want everything. So how are we going to satisfy the regulation?
Well, accidentally, or maybe not accidentally, I am involved in the standardization of the AI Act.
Yes,
I don't know if other people are as well in this audience.
I am.
Oh, you are?
Yes.
Okay. And in the bias group, I am.
Yeah, I am in the risk management part.
Okay. Oh, that's very interesting to have a chat about that then later on.
I am in the bias and data set too.
Okay. Okay. Well, we are in a good community here. As far as I understand, and I'm not there for a long time yet, so since I think it's a bit more than half a year, the developer of the system has to decide him herself what is an acceptable level of bias or whatever to call it.
Yes.
And has to comply with that.
Yes.
And everything has to be documented, etc. Because as we all know, I hope we all know, bias-free does not exist. And so there is some level, and this trade-off has to be decided upon, as far as I know, by the developer developing organization. And I would hope so. Therefore, I would love to have a discussion with you about it, Bertrand.
Okay.
That in the risk management, there already some hints will be given about this, because we have the discussion in the bias group how to interface between these two parts of the standard.
Okay.
So that would be very interesting.
Well, yes, with pleasure, but not now because I have to. I have to write my comments about the trustworthiness standard. So I have to finish this today. But okay, let's do that next week if you want.
Please,
next week
please.
we can arrange something. But yeah, I think that you're right that this is through the acceptability level. But yeah, it's a bit difficult to define exactly what is meant by acceptability level, because it's different from the medical domain where you always look at the benefits versus drawbacks, and in the European law they don't care about the benefits. It's only limiting the drawbacks. I think Sebastian, you want to add something to the discussion, maybe? Your mic is on. You're on mute? No? No. That wasn't just. Fauzi, you want to say something since you intervened about the bias?
Yeah, I agree that the bias. Yeah, thank you, Bertrand. And sorry, I joined recently the meeting because I was in another meeting, but knowing that it was discussing about bias, I have to say something.
Yeah.
Yeah, so I think that the bias is really related to risk, because the thresholds and the decision, we cannot say free of bias, but we know that we can say that at that level we consider that the bias is not relevant for that
And
usage.
it's also related to. I heard that was an important point from the Commission, that it is related to the intended goal of the system.
Yes.
So if your performance accuracy, or how to measure it, if that performance is really low, then any bias is at some point a problem, I would say. And so it's really trading off, and the accuracy should have also an acceptable level, because then you are otherwise not aiming at your original goal of the system anymore.
Yeah, sure. I think I agree that I think if the system is not performant, we will not treat at all the bias, because we will not accept the system. I think is the basic level of the system acceptance.
Yeah, true.
Yeah,
Although
Okay.
also that is a question, what is an acceptable level of performance? But yeah.
yeah.
Yes. Okay, so I stopped the
Sure.
recording. Yeah.